How is the completeness relation used in Dirac notation? Imagine you have a puzzle and all the pieces fit perfectly together to make a complete picture. In quantum mechanics, the completeness relation acts like that puzzle, making sure all the pieces fit together to describe any quantum state. When physicists work with quantum states, they often use a special language called Dirac notation. It uses symbols like vertical bars and angle brackets to representing states and their relationships. The completeness relation is a key part of this language, helping us understand how all the parts of a quantum system connect. In simple terms, the completeness relation says that a set of basis vectors, which are like the fundamental building blocks of the quantum world, can be combined to make any other state. Think of basis vectors as the alphabet of quantum states. If you know the alphabet, you can spell out any word. Mathematically, for a discrete set of basis states, the relation looks like a sum over all these states, where each term is a projector. This sum equals the identity operator, which is like a blank sheet that doesn't change anything when applied. For continuous variables like position, the sum turns into an integral over all possible positions, still equaling the identity operator. This relation is super useful because it allows physicists to insert this sum or integral into calculations. For example, if you want to find how a quantum state looks in a different basis, you can insert the completeness relation to break down the state into parts you understand better. It helps in calculating inner products, which tell us how similar two states are, or expectation values, which give the average measurement outcome for a property. Essentially, it acts like a bridge, connecting different ways of describing the same quantum information. In quantum technology, the completeness relation is fundamental. It makes sure that when we measure or manipulate quantum states, we're working within a complete and consistent framework. Whether you're designing a quantum computer, sending quantum information, or sensing tiny changes with quantum devices, this relation ensures you can always break down complex states into manageable pieces. It guarantees that the set of basis states you choose is enough to describe everything happening in your quantum system, making it a vital tool for both theory and practical applications. So, in essence, the completeness relation in Dirac notation is what keeps the entire quantum puzzle together. It confirms that the basis you pick is enough to describe any state, and it allows you to switch perspectives easily. This makes it easier to analyze, measure, and control quantum systems, which is why it is such a cornerstone in understanding the fundamentals of quantum mechanics and developing quantum technologies.